Hello everyone, I'm Alfian and today we are going to solve the HackerRank on the data structure section called the delete a node. And for this particular challenge we are using the Java 7 as our language. If you want to use something else other than Java 7, then you can go ahead. And for this challenge it says delete the node at a given position in a linked list and return a reference to the head node. The head node is at position 0 or the head is at position 0, the list may be empty after you delete the node. So in that case, return a null value. And for example, we have the linked list right here, which is 0, 1, 2, and 3. And we are pointing the head node, which is the 0 right here, that consisting of the head of the chain of all the linked list node right here, linked list nodes. And the position, it says 2, which is the parameter called the position. And after removing the node at position 2, the linked list will return with 0, 1, and 3. Why is it just returning 0, 1, and 3? It's because since the position 2 is pointing to the index number 2, let me remind you, it is about index, not starting from the 1, but instead it's starting from 0. And so the 0 starts from the 0 node here, and the next index, which is 1, and the next one, which is 2. And that the same as the position 2 of the parameter right here. So that way we are removing 2, and after we removing the node 2 right here of the data 2, then we can rechain the one dot next with the node that consisting the data of the 3 right here, and 2 will be eliminated from the existing chain. And the function description complete the delete node function in the editor below. Delete node has the following parameters: single linked list node, which is in a form of single linked list node data type, and the second parameter, which is the position, in a form of integer. So the delete node function has two parameters, and it is expecting a data type of single linked list node as the return output. And the input format, it says the first line of input contains an integer and the number of elements in the linked list. Each of the next n lines contains an integer, the node data values in order. The last line contains an integer position, the position of the node to delete. Let's say we have the sample input of 8, 26, 2, 7, 4, 15, and none. And I believe this is the linked list chains of consisting of nodes, and then the 8 is the amount of nodes contained within the chain, and we have like 8 nodes of the linked list chain, which is representing by the value of 8 on the first line, and the last line, which is the 3 right here, I believe it is the position that we need to delete the number of positions, since the number of positions is starting from the 0 right here, 0, 1, 2, and 3. So that way we are eliminating 19 from the linked list of the nodes, and the sample output, there is no 19 from the chain. Okay, so without further ado, let's solve the code. And first one, we need to assign an edge case to see if the linked list is already null. Linked list of the head node right here. So the node, we can the linked list node, we can visualize this like, let's say we have 20 and then the value of the next, and 20 right here is in the square brackets is the node itself, and then the next property is represented by the arrow sign right here. And after the next, we can take the 6, and then the from the second node we can represent this as the arrow sign, and then the next one, which is the 2, using the dot next again. And the whole 20 right here, it is in a form of single linked list node, just like the 6 and the 2 that we already described right here. So what if an edge case check if the linked list is equals to null? Let's say if the linked list is null or doesn't have any doesn't contain any of the nodes as we visualize here, then of course we are returning null, as simple as that. And that way we are not required to define our position because it is already null. So what about the next edge case? It is checking if the position of the nodes that we want to eliminate, it is already on position 0, which is in the front of the linked list. Let's say we have 3 nodes of the linked list called the 20, 6, and 2. If the desired position is 0 that we want to eliminate, which is since index 0 is pointing to the 20 node right here, then of course we are pointing the next property as our returning variable. So since next is pointing to the next node of the 6 right here, the whole node of 6, then of course we can simply return linked list dot next. Since the linked list of the node right here, the data type node, it has 2 properties. The first one, which is the data, that it is 20 right here as we visualize, and the next property, which is the next, as we visualize with the arrow sign right here. Of course we are pointing to the linked list dot next. Since the next is pointing to the 6, then of course we are returning 6 and the rest of the nodes from after the 6, which is 2 right here. And then for the next one, we can check if the position is after 0 or other than 0. Then of course we can declare our node pointer as the current node, called the singly linked list node, called the current node. We declare the current node as the pointer from the linked list, since we are using the current node instead of linked list to iterate over to traverse over the chain of the linked list node right here, instead of using the linked list directly. And then we can define our position using the for integer I is equal 0 as long as I is below the position, and then I plus plus. Let me tell you something. Let me write this after the for loop. Okay, so what if we use I equals to 0 and then I below the position and I plus plus? So for the first iteration, which is the 0 itself of the iteration 0, then of course we are pointing to the first linked list. Let me copy this part, and then linked list right here. And then for the current node, the first iteration is pointing to the 20 right here of the node, and for the next iteration we are pointing, let me use the current equals current dot next. Let me use the current node instead of current node. And then for the next iteration, which is 1, we are pointing to the index 1 of the current position right here, since we need to remove, if the position is 1, then of course we are going to remove the 6 from the node, eliminating the 6 from the chain of the linked list node. And that way, instead of pointing the current node to the 6, the exact index of the position, of course we need to subtract it by 1, subtract the position by 1. So that way we are only referencing using the current node to the previous node from the desired node that we want to eliminate or we want to delete. And that way we are pointing the current node of the 20 right here. Let's say if the next iteration is 1, then of course we are pointing to the current right here. For the position equals 0, it is already defined right here as our edge case, and then we can simply return the linked list dot next, returning the rest of the 6 and 2. And then we can simply use the we can simply add another check. If the current dot node, as long as current dot node is not null with using the AND operator, we can check the for loop, check if the current node is not equals to null, just as a precaution or edge case. If the current node is not equals to null, it is defined to check if the current node is pointing to the end of the position that is not described from the node of the chain. Let's say we only have three we only have three nodes right here. If the position is pointing to the 4, then of course the for loop will stop, and then the returning linked list will be invalid. So to prevent that from happening, preventing the position outside of the already linked list, then of course we are placing current node is not equals to null, and the I is below the position -1, and we pointing to the current node of the index 0 right here as the reference, so that way we can use the dot next of the current node and then skips this part to the dot using the dot next again from the node 6. We are using the current dot next and then dot next again, and dot next is referencing to the node 2 right here, so that way we are only returning 20 and 2 alongside each other instead of 6 between them. And then for the final check, we can check if the current node is not equals to null and the current node dot next is not equals to null, and then we can assign the current node dot next with the current node dot next again as we described earlier from the current node right here. And that way, let's say if 6 has to be removed from the chain of the nodes, then we can simply use the let me copy the linked list, the current node dot next from the position that we already altered right here using the -1 after the second iteration, which is pointing to the exact position. Then of course we are using the -1, and then the iteration will stops and pointing shifted to the left from the previous one, and then current node is pointing to the 20 right here. Since the current node is pointing to the 20 and takes the current node dot next of the next property is equals assigning the current node dot next of the same next and accessing the next property again. Accessing the next property again will ultimately pointing to the node 2 right here. So that way the conversion will resulting in linked list of the 20 current node dot next. Since 6 already has the property of next, then of course it is pointing to the 2 right here, and we are returning the 2 and skipping the 6, and 2 will be rechained to the 20. Okay, so and then we can simply return our original linked list instead of the current node. Why? It's because the current node acts as a pointer, or the one that is traversing through the chain of the linked list nodes. So let's run this to see if it works. And we have the solution, illegal static declaration in inner class solution.result. We can simply move this, since we also have the red underline right here. The method cannot be declared static. Static methods can only be declared in a static or top level type. If you if you follow the previous challenge that I already described on my previous video of the same data structure section from the playlist, you can move this function outside of the result class right here by simply moving the public static, selecting them all, and then we can simply use the alt with the arrow button, arrow down, and then we are moving this outside of the closing curly brackets from the result class right here. And then we can simply run the code again to see if it works. Okay, so let's submit this. Okay, so that's about it. I hope you understand my explanation. If you still don't understand, you can ask me in the comment section, or if you have any better solutions regarding this challenge, tell us what you think in the comment section. Thank you for watching the video. I hope you have a great day, and I will see you in the next video. Goodbye.